What if the greatest innovation isn't in what we build, but in what we choose to abandon? In the chilling vacuum where human ambition confronts cosmic indifference, two visions for returning to Earth have emerged. Each promises an egress from the orbital crucible, but only one has truly been forged in the fires of operational reality. This is the stark truth of the cosmos. Not every dream, however grand, withstands the brutal test of performance. The universe, it seems, has little patience for blueprints without proof. Aerospace's Dream Chaser embodies a future many aspire to. A sleek, winged vehicle, it is engineered for precise runway landings, designed to deliver a gentle touchdown beneath 2 gigaseconds. This less violent recovery promises unparalleled care for sensitive cargo, a distinct advantage over the jarring splashdowns of traditional capsules. Its interior is remarkably versatile, adaptable for up to 7 astronauts or substantial cargo, and it possesses the unique capability to operate as a free-flying research lab for over a year. The Dream Chaser boasts rocket agnosticism, capable of launching on Atlas V, Ariane 5, Delta, or H-2B, streamlining its integration into diverse launch schedules. Its promised runway returns eliminate expensive ocean recovery operations, ensuring cargo accessibility within hours, with an estimated refurbishment cycle of just 45 to 60 days for 15 to 30 anticipated missions. Yet, a shadow looms over this elegant design. As of 2026, Dream Chaser remains largely unproven in orbit, its experience confined to atmospheric glide tests and extensive ground development. Its narrow, unforgiving landing envelope demands high precision for aerodynamic approaches to a specific runway, a dance with gravity that leaves little room for error. SpaceX's Dragon, by contrast, has journeyed through a different crucible, learning brutal lessons not from theoretical perfection, but from the demands of reality. It was initially envisioned for truly revolutionary propulsive landings, employing Super Draco engines, each capable of 16,000 pounds of thrust. This ambitious plan, however, was cancelled in 2017. The reason? Safety certification hurdles, specifically, concerns surrounding heat shield integrity during landing leg deployment, proved insurmountable. NASA's preference, rooted in a safety culture stretching back to the 1960s Apollo program, dictated a more pragmatic path: proven parachute systems. The decision to retain parachute splashdowns for Dragon was driven by NASA's stringent safety requirements, the urgent need for domestic crew launch capability, and the lengthy certification process for unproven propulsive landing systems. In the unforgiving void, schedule certainty proved more valuable than a revolutionary, unproven landing method. This pragmatic pivot, however, did not diminish Dragon's resilience, it transformed it. The Super Draco system, once intended for primary landing, became a deep contingency safety layer. It now activates moments before impact, designed to reduce descent velocity and soften water landings, even in extreme parachute failure scenarios. This onboard thrust system provides a vital survival mechanism against issues like material wear, deployment timing malfunctions, turbulence, entanglement, or hardware failures. Dragon's architecture emerged more fault-tolerant, combining broad landing zone flexibility with parachutes, while retaining these thrust systems for emergencies. It offers a wider margin for contingencies than Dream Chaser's exacting demands. The cosmic scoreboard speaks volumes. SpaceX's Dragon fleet has completed over 50 successful cargo and crew missions, demonstrating operational consistency and significantly shortened refurbishment cycles. One capsule returned to flight just 137 days after splashdown. In early 2025, Dragon provided a safe return for NASA astronauts Butch Wilmore and Sonny Williams when Boeing Starliner encountered propulsion issues, reinforcing its status as the most dependable human-rated transport vehicle operating in low Earth orbit. Dream Chaser, for all its elegant potential, has yet to prove itself beyond the atmosphere. The cosmos cares not for elegant blueprints, but for hard-won reliability. It cares for the enduring vehicle that consistently brings humanity back from the brink, time and again. The lie of untested perfection shatters against the reality of proven performance.